Welcome back to another Q&A session with Sebastian Thrun. Thanks to those of you who submitted your questions on the forum. We'll begin with some general questions about AI, then move on to search, optimization, and game playing, and finally we'll address questions on logic, reasoning, and planning. Cool, let's get started.
It's great seeing you, students, even though I don't see you quite yet, but it's great getting your questions.
Awesome. Okay, so the first question we have is from Divya. She asks, what is the difference between artificial intelligence and machine learning, or is ML a subset of AI?
Hi, Divya. It's a great question because in most recent news coverage, you'd be tempted to think that all of AI is machine learning. Machine learning is one of the many disciplines in artificial intelligence. People have played with other things, for example, agents and logic and planning and probabilistic representations and reasoning, because it's understood that the human brain does much more than just learn. It reasons and so on. However, some of the most exciting recent advances do come from the area of machine learning, and specifically deep learning, which is one of the hottest topics these days.
A follow-up question from her is, on a related note, how is data mining and analysis related to AI and machine learning?
In artificial intelligence, many different names are used for about the same thing. Machine learning is one, deep learning, data mining, and also statistics are very related. And while each community has a different flavor of technology, data mining is more practical, machine learning is much more theoretical, statistically even more theoretical, they all address the same problem, how to learn from data. So I would not sweat which specific word is being used. When someone has an argument with you in a bar using the wrong word, just smile and, seek the restroom and come back until the conversation topic changes. Because in the end of the day, they all do very, very similar things.
That's a great advice. So Darshan asks, what are the limitations of artificial intelligence? Is there any particular problem that AI can never solve?
Darshan, good question. Every single time the experts in the world agreed that a problem cannot be solved by AI, it was solved a few years later. So it's a very risky thing to propose something can't be solved by AI. That doesn't mean everything will be solved. Okay, so to give an example, historically, when I grew up as a student, it was pretty clear that AI could play good chess but never beat a world chess champion. And then came 1997, Deep Blue, and Kasparov was defeated. And today, a phone like this does play grandmaster chess. But the community cleverly pointed out that Go cannot be defeated because Go has so many more combinations. There's more potential Go board positions than there's atoms in the universe. How could a computer ever beat a human champion? Come 2016, bang, AlphaGo beats the world best champion. Car driving. When I was starting my professional career at Stanford and Carnegie Mellon, it was made clear to me that computers would never be able to drive cars as good as people. And the judgment is still out there, but I think they're doing a darn good job driving, and they're getting better from year to year. Now, to be a bit more critical, I think if you look at the advances recently, they're all on very specialized, highly repetitive things. For example, AlphaGo doesn't know how to play chess. Jeopardy doesn't know how to become a lawyer. And my self-driving cars, they can't fly airplanes. We don't have something universal yet where AI goes to school for, say, 18 years and then takes a nanodegree and becomes this broadly minded, like a really, really smart person who can transfer something from one skill to a new skill. The day when AI becomes like Einstein is going to be a big deal for all of us, and it hasn't arrived yet.
Katya asks, do AI researchers and developers experience changes in how they perceive the world, especially if they work intensively on a problem for a long time? For example, you often hear that artists and musicians perceive colors and sounds around them differently, or that doctors can diagnose illnesses just by looking at people. What about AI people? Do we begin to think like an AI if we work in this field for a long time?
Katya, that's a great question. We take less LSD than artists, and as a result, our color perception isn't quite as affected. Okay, joking. Might actually even be inaccurate. Here's the thing. When you become a professional, then things look differently for you. If you, for example, look at a rock, it looks just like a rock. But if you're a geologist, you can read stuff into the rock that no one else can see. And it's true for us as well. There's this element of introspection where people ask themselves, how do I reason and how do I make decisions? The problem with that is introspection is not a great tool. We often believe, I'll give you an example. I argue with my family, right? And I'm completely convinced that I'm logical. But when I really dive in, I often find that my gut decision was an emotional even subconscious decision, and the language is just a way to defend it and articulate it. It's a big conundrum right now how decision making happens or how perception happens in the human brain. And I think generations of AI researchers have been misled in some extent by their own interception. The early AI was all about reasoning and all about logic and reasoning. And I would argue while we do employ logic and reasoning, the vast majority of the brain doesn't do conscious processing and certainly doesn't seem to follow logical rules. And it's only now that we understand that machine learning and similar things play an at least equally important role. So we do this, but I want to be just careful. The second reason why I'm more careful is actually another one, which is about 15 years ago, flight was invented, controlled motorized flight in Kitty Hawk by the Wright brothers. And up to that point, people had studied flight and looked at birds which could fly and tried to be like birds. And it was believed that if you get the right wing shape, or possibly even flapping wings, that you could fly like a bird. Sometimes these superficial comparisons don't hold up. Flight, in the end, the big invention was actually not the wing shape. It was the controllability, that you have controls to change the wing shape in mid-flight. And that was something that's now visible, and birds do the same thing, but the intersection at the time misled lots of people. In fact, the experts at the time had agreed that flight is impossible.
That's true. What would you recommend students to do when they're sort of beginning to step into this field? How can they start to think more like an AI professional?
It's very, very simple things. Build a system. Try it out, whatever it is. Make your smartphone smart by having its, do a deep network to recognize something on a camera stream and just build it. When you build something, say you buy a robot from Amazon for $100 and have it navigate from your bathroom to your kitchen, okay? And just try that out. When you build it, you run into so many interesting problems and they will surprise you.
Yeah, I guess you stop thinking about some of the broader issues and focus more on what's at hand.
Yeah, I've been to maybe 200-300 AI conferences in my life, and people there debate algorithms like on architectures like crazy. It's really important to have a planner that has this characteristic, and here's my new planner, and it can deal with this hypothetical problem. I'm a big fan of end-to-end systems. I'm not a big fan of arguing components. So if you come to me and say, I invented a new planner, I'll smile and say, good for you, right? But if you tell me, look, I want to build a robot that navigates my home, and as a result, I had to build this new planner, then you have my full attention. I took the same methodology into the Google self-driving car team, where we built an end-to-end system literally from day one that drove literally on public streets like a week or a month in, and it drove for like 3 meters before we had to take over, right? Because we hadn't gotten it right. But after we had to take it over after 5 meters or 10 meters, whatever, over half a kilometer, we realized these are the 5 most important problems. And then we didn't have to argue anymore, we just had to solve them.
Nice. It's a very daring approach. I'll switch our conversation to some questions from search optimization and game playing. So Varuna asks, what are the applications of adversarial search apart from games?
Adversarial search is one of these fields that's very, very active and very interesting. There's actually now adversarial machine learning, which is getting very, very hot, where you train 2 machine learning modules at the same time, one to generate fake data that gets mixed into the real data, and the other one to distinguish those two. And in this adversarial process, you build an amazingly great fake data processor that then trains the one that you really care about, which does the task itself even better. The world is full of many, many players, and it is often false to assume that you can make a decision in a vacuum. Say, for example, you go onto the stock market. What moves stocks often, I'm not a stock expert, and I'm not giving stock advice here, it would be illegal. What moves stock is often the perceived behavior of other people. And if you can pre-guess how other investors react to certain pieces of news, that might actually be a better strategy than asking how much is this company worth in the long run, at least for day trading type activities. And many, many hedge funds use this as a way to give you an example. At some point, I remember many years ago, there was a released article that talked about that United was about to go bankrupt, and it was a historical article. But all the chatbots picked up as, oh, United is about to go bankrupt. And then immediately the stock dropped by 9% in a single moment. And there was one of these cases where it dropped not because some analysts had found United would go bankrupt, but they all realized if this article comes out, everybody else will sell, let's sell first.
That's true. Let me jump to another question related to adversarial search. So Shuping is asking, Are there any connections between adversarial search, especially in probabilistic scenarios, and multi-agent reinforcement learning, such as in competitive Markov decision processes? It seems to me that evaluation functions for adversarial search and reward functions for reinforcement learning are similar to each other. Is that true?
Yeah, Shuming, you're completely correct. And I think historically the reinforcement learning community and the adversarial search community are somewhat separate. And every community has its own dogma. I think the interesting new research always emerges at the intersections of two fields. So I'm not familiar with many papers that tie together reinforcement learning, but the notion of expected, unexpected, discounted future reward is inherent in both. That seems to create an opportunity for research.
So this one is about alpha-beta pruning. So part of the readings for the students included Richard Korf's 1991 paper on multiplayer alpha-beta pruning. And so I don't know how to read their name, but their handle is LTF Schoen. They're asking, can you point out additional resources for better understanding multiplayer alpha-beta pruning?
I take the fifth here. I have not read Richard Korf's paper, even though I like Richard Korf a lot. And boy, that's now above my head. I do fully understand single agent alpha beta pruning. I love it.
Yeah. I guess like your advice last time, for multi-agent alpha beta pruning, I guess just working through some examples is a good idea to better understand the algorithm.
I mean, when I get stuck in something, and again, I have not read Richard Korf's paper and I apologize, I try to implement a very simple example, and maybe the example given in the paper, or maybe much simpler, and really dive into it. When I was a PhD student, I made sure that every paper I read, I understand every sentence. And I remember being stuck in a paper on gradient descent and something, and I spent 2 weeks on it, and I really want to understand it. I implemented, didn't quite work, and I couldn't understand the math. And then like 4 or 5 years later, I ran into the author and said, "Hey, you wrote this paper over there," and I got almost all of it. It was a brilliant paper, except for the last chapter, the last section. I just couldn't. He said, "Oh, I just wrote it. I didn't really care. Didn't even think about it." So it was obviously wrong.
Oh.
so I try to implement it. Try to discuss it with friends. It's actually really useful. And I can tell you, in my life, when I spent a lot of time trying to really understand something, this is about the best spent time. When I just hushed over things I didn't understand, I learned much, much less. So even though I spent 2 weeks on a false formula, the discipline of thinking through this and recognizing I couldn't make sense of it, I think strengthened me as a result.
Mm-hmm. That's great. There is a very interesting follow-up to this. Do you know of any initiatives that go about rewriting or summarizing research papers or explaining algorithms in different ways so they are more easily understood by laymen? For example, using visuals and animations like in Udacity videos, or open source initiatives, something like the Plain English Foundation. I think that's one example of a firm that does something similar but in a different domain.
Yeah, I would love someone to do this for artificial intelligence. Yeah. I would say Peter Norvig and Stuart Russell are my closest approximation, that go to all the papers and write the machine learning book, but it's obviously just a small sliver of what could be done. Occasionally I come across some totally amazing animations. I have some reason on deep learning where you had an interactive tool where you could play with parameters and get some different outputs, but I've not seen a central repository for this. One of the main issues, by the way, is as a researcher, if you're a PhD student, you don't get rewarded for building something that many people use, especially in open source, if it's not quote unquote novel. You get rewarded for writing a paper that ends up at NIPS or something like this. The people who take it on them to unify these things are often not rewarded in the end, unfortunately. But if someone out there hears me, I would be a big fan of someone even taking a small slice, for example, taking the basic machine learning course, and put together all the stuff you can find in animations into a single site. That'd be great.
Yeah, I think it would be a worthwhile initiative for both the person who's doing it and others who would be.
Yeah, it would be great for the students, and we would love to work with that person.
Another one related to constraint propagation, but slightly on a different note. So constraint propagation basically creates constraints based on several different rules or factors, but the most important set of rules are inherent in the game or problem that is given. So he's asking, so this is Enil. Enil asks, can you give us some perspective on how an AI agent can learn these rules dynamically? That is, when you're not given knowledge about the problem domain ahead of time.
This is one of these like wonderful $10 million questions. We humans obviously spend a lot of time in sub-symbolic learning where we don't use rules, like visual learning is a good example. A good amount of our brain is dedicated to our visual and olfactory and audio processing. And then at some point we've been able through language to be able to emerge something called rules. And these rules are written down in books that really help us guide our behavior. So they're very, very powerful. So one of the big questions is coming up all the time. How do we actually take something that's like sub-symbolic and noisy and fuzzy and extract the essence out of it? I think it's going to be one of the great problems going forward. In the classic history of machine learning, most of the early work actually focused on extraction of rules. There's things like decision trees and many other algorithms that were developed in the 1980s and 1990s that really would extract rules from data, but they're very limited. The data spaces are very small. There would be like 3, 4, 5 dimensions. In fact, if you Google the word Monk's problem and my name, you'll find a report we wrote in the 90s with the 21 other prominent machine learning researchers, and we had a little toy game of little toy monks that had to be, toy robots had to be classified, and we extracted rules and we had a competition. And in some of those, even neural networks won. The big change now is that our deep networks that we're training right now are massively complex. And digesting and finding a rule in a deep network is akin of trying to take a human brain and cut it open and understand where the rules are. So it's an open question. I would encourage people to think about, is there ways to extract rules? Because if you could do this, then you could communicate what you learned about the domain to other people and also to other AIs much more easily.
Okay, so extracting rules could be one sort of action that you could go for, but you could also design a system that is agnostic of, explicit rules, but where those rules are sort of embodied through the architecture itself.
Yeah, and it's a wonderful open question, honestly. I think, obviously when humans adopted speech, we accelerated as a race over chimpanzees. In part we could communicate, so we could teach each other in an efficient way, much more efficient way than a chimpanzee would teach their kids. But secondly, we could also reason in our brain about things and think things through, right? And put up hypotheticals in our brain. What if I buy the red car, and what if I buy the green car, and think about what the applications are. What if I in this apartment or that apartment, and make a spreadsheet of things that we care about. And they're all rule-based in some sense. They're not emotional, whatever, right, point clouds. I would suspect that once we discover that deep learning has some structure, if you were able to harvest that structure somewhat, we might at some point in the future be able to make these networks think in a way that's more human-like. And that could potentially be the key to take our narrow focus of our current networks and augment it to a much broader range of problems. Mm-hmm. And it's a sheer speculation. I have no clue whether that's right, but it's certainly an interesting question. In the history of AI, there's always been the rule-based people and the machine learning people that are not rule-based, and the pendulum has always gone back and forth. And right now, it's squarely in the world of no rules, okay? But it has to come back to rules because symbolic information is so important.
Yeah, that's a very good insight. We'll keep an eye out for where the pendulum is swinging. I'll wrap up this section on search optimization and game playing with, again, Varuna's question, kind of related to what you were saying. What do you think about the future of search algorithms with the advancement of machine learning techniques like deep learning?
I think we're just at the infancy of search algorithms, and I honestly believe there's an opportunity to reinvent an entire business on search, to be honest, even though Google and others have done a phenomenal job, in my opinion. Yeah. And the reason is, just imagine you want to build a really great companion on the Alexa platform, okay? For those of you who don't have Alexa, it's a wonderful microphone array that's listening all the time. I love it. It's very similar to the telescreen in George Orwell's 1984, so you might hate it. But I love it. We come home and it switches on my lights. But I can't really talk to it in a meaningful way. I can't say, hey, look, make sure that Shanaz knows about my meeting at 9 o'clock. And hey, tell me something about what was said in this meeting over here, and can you give me a cooking kitchen recipe? There's an element missing. It's still very basic. For me, search is not about querying information with keywords. It's about having a partner, having someone like an assistant whom I can trust, okay? They're not just accessing web pages anymore. They're possibly opening my windows or accessing my calendar program. So if I were to think about something really cool to do in AI, I would say let's take the Alexa platform and completely reinvent what search really means. And I think we are really just at the infancy today, despite the fact that Google is a $400 billion company.
That's very inspiring. A lot of our students will probably end up doing a lot of these tasks that you're highlighting.
I mean, working with Alexa, yesterday I spent all day on Intersect. You should all come to Intersect, by the way, with the head of the Alexa program at Amazon. And I can tell you, it was fascinating. They understand they are just at the beginning, and they're hiring, I think, hundreds of people into the team, engineers, like Nanodegree students. In fact, he hung out there the entire day until the very evening because he loved our students so much. So thank you if you guys were there. And he really believes that there's to be a really, really strong growth of this kind of capability. Because if you get this capability done, you can transfer it into a watch, into your car, wherever you are. That'll be such a groundbreaking innovation that I think we're going to look back and say, oh my God, we did keyword-based search in a web browser? Holy cow.
Yeah, that actually leads us to a nice transition into the logic, reasoning, and planning section. Because I think what you're saying is, look at the search algorithms not just for any kind of search, but for search in very novel ways, for instance, when you're creating plans. So one of the questions that we got from Letitia is, could you give us some examples of planning applications, like do self-driving cars use planning?
Yeah, so planning is used a lot in self-driving cars. And I can only refer to the work that I did back when I was running the Google team or the DARPA Grand Challenge team. There were at least 3 or 4 different types in which planning occurred. There was the more incremental approach where you'd say you're driving down a lane and you don't really want to leave the lane and turn around at right angle because it's just not a valid driving action. But you want to kind of nudge around things in a safe way. And that's planning. It's just very constrained planning. We solved that really, really well. And then there's slightly more complicated planning would be in the DARPA Urban Challenge. We were asked to do like 3, 4, 5-point turnarounds. So 3, 5, 7, 9-point turnarounds. They're all odd numbers. So we had to come into a dead end and then understand how many turnarounds. It's still very constrained, right? It's not the general planning purpose. But in the end of the day, there's always this component where you have to do freestyle motion. So there might be a traffic accident in front of you, and you might want to very slowly and carefully zip around and find a new path. So you might be in a parking lot, and then the cars might be parked illegally, and then it becomes a very open geometric problem. We are able to solve this almost in real time. There's a paper on A-star, an extension of the A-star by Dmitry Dolgov, that really came up with a solution for this. But when you go into the general purpose, you could even imagine multi-agent planning problems. Peter Stone at University of Texas Austin released a video a few years back showing how self-driving cars could navigate an intersection without a traffic light. And it literally looks like, cannons shooting at each other, and magically these cars zip by each other without touching each other. It's a phenomenally great planning problem. Once we have only self-driving cars, you bet they're going to go through intersections without traffic lights. We're going to be much, much faster.
I was wondering if there is a unified standard open source framework for representing all the knowledge in the world using formal logic. Kind of like Wikipedia captures all the knowledge in natural language, but formally. And his intuition there is then we could obtain further deductions based on that.
Yeah, there is. And there's a project called CYC, that attempted to do this and ended up to be a colossal failure. And the reason is, when you write down everything you know, like that my father is older than me and is always the same way. Not all people are famous, even though most people you find on the web are famous. Like stuff like this, what the team never was able to do is link these things together in a meaningful way. There's so many different entities in the world that are disconnected, coming up with a coherent way of presenting this, and to the point that reasoning was possible, failed. If I commend you, read up on look on the web on Psych. Doug Leonard was the very, very great and super smart pioneer that took it on himself to build this project. But after more than 20 years of work on it, it unfortunately didn't give us the right solutions. So from an AI perspective, a sheer broad inference machine doesn't fail on the inference side, it fails on the knowledge acquisition side of writing these rules. That's why I'm so excited about machine learning, which takes these more fuzzy rules and can put them and build these internal rules like deep networks that it can deal with that are much more fuzzy, much more grounded in real data and in the real world. Now, deep learning doesn't have the inference capabilities we want, right? It doesn't spit out books. So the answer is somewhere in between. I would argue, to be precise, the world's knowledge and inference is actually in the Library of Congress and all the books that are written there. But we haven't quite figured out how to do inference with those.
Interesting. So maybe it's an interesting strategy to maybe keep this knowledge in natural language, but then process and reason with it as and when required.
Yeah, I would love to see projects that say, let me get all the physics books in the world, and then also all the data that I can about physics in the world, and then maybe I can pass a physics exam. That would be really fantastic.
That would be awesome. All right, last question for today from Charles. He's asking, how can we begin to combine the different generations of AI so that we can get the logic and planning from the first wave of AI systems together with the intensive learning and function fitting algorithms of today?
The way I would do this is I would seek myself a problem that requires both, to be honest. I would not start on the mechanism side and say I religiously want to integrate this and that. I would say, what problem exists in the world that cannot be solved without that integration? And that's what I would work on. I remember there was a field that was called cognitive robotics, and it was run by people like Ray Reiter, who since unfortunately passed away, a super smart guy who was enamored with logic and felt logic ought to be really great for robots because robots have to think. There was the belief when I was a grad student. And in many, many years, they weren't able to make robots do something interesting because it turns out robots don't have to think that much. The type of things that robots could do at the time were very simple things. They could like follow a corridor, right? Or they could like honk a horn or recognize a person. They never reached the level of human capability where you really had to do serious problem solving. So many AI researchers, unfortunately, approach problems from the mechanism side and say it wouldn't be great to have probabilistic roadmap planning together with multi-agent or machine learning. I would do the opposite. Find yourself a problem that you believe is solvable and where you believe these mechanisms are needed and try to solve it. And if you solve it and you still need those mechanisms, you have a phenomenal research results.
Cool. Thank you for that advice, and thank you for joining us again. Until next time.
It's a pleasure as always. See you guys.